Hello, and welcome to the experimental portion of Chemistry 103. Today we are going to be doing the density and specific gravity experiment, which is really just measuring the density of various substances, among them a solid and a couple of liquids. Then we will be measuring the specific gravity of a liquid. I will be modifying the procedure slightly because I was not able to find the correct hydrometer. So we're going to use one that's designed specifically for distilled alcohol to show you the proof of concept. And then we will determine the density of a solution by displacement, the density of a solid by displacement of a liquid. So I'm going to discuss the concepts and the procedure, and then there will be videos of the actual experiment interspersed among the discussion. So they say that this lab takes 2 hours, but I highly doubt that it would take anybody 2 hours to complete this experiment. Normally people get it done in like 45 minutes. Really, this is just to introduce the ideas of working in the laboratory, get you used to the various types of measurements in an incredibly safe and low risk environment. The concepts involved are going to be the density, which we discussed in lecture, which hopefully all of you have watched at this point. And if you couldn't hear the audio on the first version, I've uploaded a louder version so that you can go back, hopefully, and catch anything that you may have missed. But the density of a substance is its mass divided by its volume, and it has units of grams per milliliter, which is equivalent to grams per cubic centimeter. Specific gravity is the density of a substance, specifically a liquid, most often, but sometimes a solid, divided by the density of water, which provides a reference value, allowing you to quickly compare multiple values to a standard. And in class, we mentioned volume measurement using displacement of a liquid. Here, the scan quality is poor, so you can't really see the image, but it's the same as this one here from the lecture, where you see liquid that is in a graduated cylinder, and it's filled up to 35.5 milliliters. And then you put a piece of zinc into the cylinder, and it increases the volume to 45 milliliters. We will be using a similar concept in this lab today to calculate the volume of a bunch of nails that I found. And instead of a graduated cylinder, I'm going to be using a measuring cup, and we will discuss the various levels of accuracy of the two instruments. And if you recall, objects float or sink in water based on their density compared to water, so the specific gravity of a substance will determine whether it will sink or float, because it measures whether it is more or less dense than water. And just quickly to review, this is specifically referenced to water at 4 degrees Celsius, so if you're significantly warmer than that, specific gravity might go down a little bit because the density of water will decrease. All right, so back to the experiment. You can also determine the density of an unknown solid by plotting a number of mass and volume measurements and then taking the slope. So the way that you do this is that you start with a beaker with water or a graduated cylinder with water, and then you add increasing amounts of the substance to be measured, measuring a new mass every single time and keeping track of the volume, and then you make a graph of those values. And if you put volume on the x-axis and mass on the y-axis, the slope will have units of grams per milliliter. So on to the procedure. It says goggles required, but you're using water and a non-poisonous unknown liquid, so you wouldn't really have to wear goggles for this, but in order to establish good safety practices, goggles are usually required at all times in the lab. So lab is split into 3 parts, parts A, B, and C. Part A is in turn split into 2 parts, where you measure the density of water and then the density of an unknown liquid. So in this case, we have part A1 that says to use a 50 milliliter graduated cylinder to get some water and to get a 100 milliliter or 250 milliliter beaker. I have instead gotten a 2-cup measuring cup, and we are going to first weigh it. We're going to record its dry mass using the kitchen scale that I have. This kitchen scale only measures in increments of 1 gram. So once we've turned it on and changed it to the appropriate mass units, it reads 0. And then we place the beaker on it, and it weighs 658 grams. Then we will adjust the camera so that we can see the meniscus of the water that we are about to pour into the beaker. And then we will pour water in until the meniscus reaches one of the demarcation lines on the side. I'm going to shoot for somewhere above 200 milliliters. And after a bit of trying, I will get to approximately 275 milliliters. So you can see there is only a demarcation every 25 milliliters on the glass. And the meniscus, once the camera is adjusted so that it's at the right level, you can clearly see the meniscus is basically right on that line. You can imagine that the error of this measurement might be as much as 10%, but for the purposes of this simple experiment, it will have to do. If you now record the mass of this beaker again with water in it, you can see that the balance reads 943 grams. And that now the density can be calculated using the equation in the manual. I will leave that to you for the report. So I will provide a Google Sheet with the data, and I will ask you to calculate the various densities and specific gravities that the questions ask for. And we'll discuss that afterward. Okay. So now moving on to part A2, I have prepared another solution which we will pour into the same beaker with the same mass, and I will do my best to hit one of the demarcation lines with the liquid level, and we will record the density of this new liquid in the same way that we measured the density of water So in this case, the mass of the beaker is still 658 grams, but now the mass of the new liquid is 876 grams and 200 milliliters. So you can see already that it's less volume, but the mass is higher than you'd expect, and so the density is going to be larger. But I will let you do that calculation on your own. All right, now moving on to specific gravity. The first part of this asks you to calculate the specific gravity of water. Specifically the water that we used in this experiment, and you're going to divide the density that you calculated in part A1 by the density of water at 4 degrees Celsius, which is 1.00 grams per milliliter. And then you will, in part 2 of part B, calculate the specific gravity of the unknown liquid sample, and by dividing its density from part A2 by the density of water, which is 1.00 grams per milliliter. Then, once you've done that, you can do that when you fill in the report. Now I'm going to show you a real-world application of a hydrometer. I mentioned at the beginning, I couldn't find a real hydrometer, I guess you would say, because I'm dealing with limited resources in a quarantine right now. However, I do have a hydrometer used specifically for brewing, and it reads alcohol percentage, which is one application of specific gravity and can be a useful tool. So I'm going to show you how a hydrometer can be used. First, you fill the hydrometer with the liquid that you're trying to measure, in this case, the alcohol content of. But if you were using a regular hydrometer, then you would fill it with the liquid that you were trying to measure. And I'll actually show you an example of a liquid that doesn't work with this hydrometer. So the first one is we're going to test it with water to make sure that this is functioning correctly. So if you put the hydrometer into the water and let it stop bouncing around, then you see that the meniscus is aligned with the 0% marking, which means that it is 0% alcohol and 100% water. Now, the second liquid I'm going to try is shown here is some vanilla flavored liqueur, which is a very sugary, low alcohol content beverage. And it is an example of something that doesn't work with this hydrometer because it has so much sugar in it that it causes the hydrometer to float too high, and it shows a negative alcohol content value even though it is 24% alcohol. So in this case, you'd need to use a regular hydrometer, which would be calibrated to water, and then you would have to do a little bit more math to figure out how much alcohol was in your beverage. However, if we use the same hydrometer to measure the specific gravity, or rather alcohol content via specific gravity of some Jose Cuervo 80 proof tequila, we pour that into the hydrometer and put the floaty device into it, and you can see when you go close up that the meniscus aligns directly with the 40 marking on the hydrometer. So you can see this is working correctly. The listed alcohol content on the bottle is the same as the measured alcohol content on the hydrometer. So that is a fun little example. And then now to show you the reason that I bought this in the first place, I brewed some mead, which is a fermented honey drink, and I'm going to test the specific gravity of that. Now, putting that into the hydrometer and floating the bulb, you can see the meniscus is sitting right around 10% alcohol. So that this drink is probably maybe a little bit more than 10% alcohol, because there are certainly some residual sugars still floating around in there. However, it's probably not much more than 10, maybe up to 13 or 15. So that's specific gravity. And that's how a hydrometer is used. So that's part B. This is a little picture. I think my camera showed a better picture, but see here, this shows specific gravities higher than water, and if the hydrometer goes above 1, then it shows specific gravities less than water. So now moving on to the density of solids. Now, using the same technique as before with the measuring cup full of water, I am going to attempt to measure the density of nails. And I'm going to put in some handfuls of nails until the meniscus increases by a measurable amount using this measuring cup. So in this case, the water level is starting at 275 milliliters, which is the same as before because I just used the same water. And then we take the nails and we put them into the beaker while the beaker sits on the balance, and we can see that once we've put in about 25 milliliters worth of nails, the mass has increased to 1,140 grams. So this is from 943, which was the mass of the beaker plus water. So 25 milliliters of nails increases the mass from 943 to 1,140 grams. Now, once you calculate the mass and the volume displacement, you can calculate the density of this metal and compare it to Table 1, which shows the densities of various metals that are commonly encountered. So part of your lab report will be calculating the density, and then based on that density, telling me which metal you think the nails are made of. Now, graphing mass and volume. So in this case, this would definitely require a graduated cylinder, but what I think that I'm going to do is provide you with data for some coins, some such as pennies or quarters, and I will give you a series of masses and volumes based on the procedure shown here, where you add a small number of coins, record the volume displacement and the mass, and add a small number of coins again, and then measure the volume displacement and the mass again, and you repeat this a few times to get several data points, which you will then graph on Google Sheets. which I will demonstrate, and then you will submit this as part of your report as well. So the slope of the line formed by the graph of these data points has units of grams per milliliter and is equal to the density. And yeah, I will show you I will provide this data sheet for you and give a demonstration on how to graph things, and then you will submit that to me. All right. Okay, one last thing about the report sheet. So this is from the PDF that I'll be attaching to the video link, but I will also be providing a digital report sheet on Google Documents via Google Classroom. So this brings us to the point where I need to introduce you to Google Classroom, because that will be the method through which I accept all assignments for this course. So what I will do first is I will talk about the lab report that I've generated for you in this video, and then I will post a separate video explaining the whole process of logging into Google Classroom for this course for the first time. I have posted a link to that as well on the Blackboard page. So here is all the data that we have collected for this experiment, and then I have, for part D, provided data for you. So we'll take a look at what that means. So this is the Google document. You will each have your own copy that will be attached to an assignment, which you should upload. You should edit the document attached to the assignment and then hit the submit button on the assignment. So here you see from our measurements earlier, I've put down the volume of the water, the mass of the beaker, and the mass of the beaker plus the liquid. My expectation is that you calculate the values in red question marks. So you should be able to perform subtraction and division operations using the correct number of significant figures, of course. Then there's here I've provided you for the density of an unknown liquid, and then the same for the specific gravity. The difference here, for specific gravity, I have added questions about the specific modification that I made to the procedure using a hydrometer specifically for alcohol. So answer these questions based on that. And then the density of the solid. I gave you the mass of the nails that I added, and the initial and final volumes of water. From that, you should be able to calculate the volume of the nails and therefore the density of the nails. From that, and table 1, you should be able to calculate the type of metal, or tell me the type of metal. And then for part D, I have created a data set, and I expect you to graph that data set and then calculate the slope of the scatter plot that you generate, and then from that slope, which is equal to the density, I expect you to identify the type of metal in question. So this is a Google Sheet that is attached to the assignment that all of you will see when you log into Google Classroom for the first time. So I have created a simulated situation where you have taken a beaker containing 75 milliliters of water, weighing 75 grams because water has a mass of 1 gram per milliliter, and then you add stacks of pennies to the water, and it increases in volume and in mass. So the way that you graph in Google Sheets is similar to the way that you graph in Excel. The best way that I've found to do it is to highlight the data and then click Insert Chart, and it will generate a chart with mass on the y-axis and volume on the x-axis. This says units of grams per milliliter. Now, the way that you then manipulate this data, you click on the line and you scroll down in the chart editor menu to trend line, and then it will give you various options. Then it will have this label button. So you click on label, and I would say use equation. So it will show the equation. Get rid of that again. So that's how you make a graph. So you'll make it yourself and then submit it to me. And then the value you get for the density will be placed here. And then that's equal to your density. And then you go to table 1 and figure out what type of metal that is. It's pretty straightforward. The pre and post lab questions that are included in the report sheet or in the lab manual PDF that will be attached to the video, those questions will be in the quiz instead.